3 divided by 1. And finally, this one gives us log 3. So we have same answer like the second one, log 3. That is the third one. Let's now look at the fourth one. So fourth one, we have a problem. First one, there was no number in front of the log, so it was easy to apply the laws. When there are no numbers in front of the log sign, it is easier to apply the number. But the moment a number comes, it means we need to redo something before we can work it out, else we cannot be able to solve this one. So what are the things we need to do to be able to work this 2 log 3 plus log 2? Let's find out. Let's see how we can work this stuff out. So let me pick the question and then we can do it together. The question says we should solve 2 log 3 plus log 2. So this is my problem. This 2 here is worrying us because the moment you have a number at the back of the log, it means we cannot apply the laws. Because all the laws we were applying, we normally have the log without a number at the back. So our first thing to do is to see how we can clear this 2 from there, and then we can apply the laws. So we recall that law 3, if you remember, says that if we have log a x raised to the power n, we don't entertain powers in logs. So we said this n will go to the back of the log, and then you have n log ax. So if you watch this law, that is what the first term is experiencing now, this one. You see that it's in the form of n log ax. So if we want to remove these 2, where are we sending? We need to remember where it came from. The 2 came from on top of this 3. So we are sending it back so that we can free ourselves of any number at the back of the log. And so in rewriting this one, we can rewrite it as log 3, and then the 2 will go and sit on top. Raised to the power 2 plus log 2. Right? So from here, we now see that there's no number at the back of any of the logs. So we can go ahead and apply the laws. So in apply this one, we can apply law 1. Law 1 says that when it is plus, just multiply the 2 numbers on the platform. So this becomes log 3 squared is 9, okay, multiplied by 2. So finally, our answer becomes log 18. 9 times 2 have 18. And then we stop here. Any question before I do the 5th one? So far, the examples we have done. If you have a question, you can ask before I do the 5th one. Any questions so far? Okay, so I presume you are with me as we move along. Let's move to the 5th question. Let's move to the 5th question. Now, the 5th question, we have it here, half log 4 minus 6. We use the same strategy like we just did here. The same strategy can be deployed to work. Half log 4 minus log 6. So let me create a space and then we can work that one out. We'll still have a problem. There's a number at the back of the log. We need to clear it before we can proceed with what we are doing. So we use the same strategy we used for the previous one in tackling this current one that we have. So we can start now. Question number 5. Half log 4 minus log 6. Let's go. So half log 4 minus log 6. We don't want any number to be at the back, so we are sending it back with a third log. So this one becomes log half log 4 minus log 6 will be equal to log. The half is coming on top of the 4, so you have 4 to the power 1 over 2, like this, minus log 6. So this one becomes 4 to the power half. If you remember the indices we did, this 4, you can break it down as 2 raised to the power 2, like this, but there is half there. Remember the third law of indices. This one can be written as multiplying the powers 2 times half. So this and this will cancel, and you have 2 raised to the power 1. And any number raised to the power 1 is the same number, so that is 2. So all this will give you 2. So we have log 2 minus log 6. Then we can use the second law to finish this up. The second law says that when it is minus. So I've muted everybody. If you want to ask a question, then I can release you. So we have log 2 minus log 6. We go ahead and then we use the second law to finish up. So if you remember the second law, it says that we should just divide the top by the bottom. So this one will become log 2 divided by, let me write it in a better way. So you have log 2 divided by 6. 2 will cancel itself 1. 2 will go here, 3. So the final answer is log 1 over 3. This is the final answer for question number 5. So that takes us, yes, Jonathan, let me unmute you and then you can ask your question. Yes, go ahead, Jonathan. Yes, Jonathan, go ahead. Unmute yourself and ask your question.
Sir.
Yeah.
I want to know whether the final answer, that is the log
Yes.
1/3, can be written as log 3 to the power -1, right?
There's no need even changing it to 3 to the power -1. You don't need it. You can just leave your answer as 1/3.
Yes, sir. Because the reason why I'm saying that is that if it becomes log 3 to the power -1, which means that the -1 is going to go behind the
Exactly.
log. So
exactly, which we don't want to encourage.
Yes, sir.
So you leave your answer this way. Any other question? That was a good question. Any other question? Okay, so I'm sure the questions will start coming as we solve more problems. So let me move to question number 6. Very funny. 2 minus 2 log 5. How can you solve this one successfully? We'll have to use some trick here. 2 minus 2 log 5. Now, if we are not able to rewrite this one in a certain way, we cannot solve it. So I want to tell you that the same thing you are seeing here, we can write it as 2 log 5 2 log. Okay, let me not confuse you. I wanted to introduce some number bases, but let's go the simple way. So watch this one. 2 minus 2 log 5. 2 minus 2 log 5. So we have 2 minus, now this 5, this 2 here will have to go here. So you have 2 minus log 5 squared this way. So this becomes 2 minus log 25. Now watch what I'm coming to do. I told you from the beginning that anytime a log is standing like this and there is no number at the down here, it is base 10. It's the same as writing log base 10 25. Okay, log base 10 25. So in rewriting this one, this 2, I can write these 2 as 2 log 10 minus log 10 25. If you don't understand this, raise up your hand and let me explain to you why I've written this 2 as 2 log 10. Because I want to introduce a log into it so I can combine the 2. Right? So Frederica, you don't understand. Let me explain to you. There's a law we did the other time. We said log AA. Log AA is the same as 1. It means when the base and the number are the same, the answer is what? 1. So in the same way, I can also tell you that log, let me create some space here for you and then keep on explaining. So here I can also say that log 10 is 1 because here and here are what? The same. Okay. So if I know that this one has log 10 and I want to introduce log 10 here, it's just a matter of pushing log 10 there because this big thing you are seeing here, it is 1. So if it changes to 1, we'll come back to the 2. So that is the trick. This we call it mathematical tricks. Sometimes you have to use some tricks to combine numbers. So I just know that in log 10 is what? 1. So it's like writing this one as, yes, Festus, 2 times 1, the same as what? 2. Yes, Festus, ask your question.
Hello, sir.
Yes, go ahead.
Please, where from the log 1025?
Yes, so when we started, we said that we are using the third law to send these 2 on top of this 5. So we brought it and then we had 5 squared. So 5 squared is the same as 25. Then I told you that when you are given a log and they don't write any number below here, it is base 10. Sometimes they write it, sometimes they do not write it, like the way you have it on your calculator as log. It is base 10, but they don't write it. Okay, so that is why I brought this 10 here. And then this one gave us 25. That was how come we had a log 10, 25. Festus.
All right, thank you, sir.
Are you sure you are okay with it?
So I'll take it like that.
No. Don't take it like that.
No,
Let's agree before you take it like that. Now, step by step.
Sir, please go over again. Thank you, sir.
Step by step. Now, do you remember this law we wrote? Log A X N. Third law, we said bring the N at the back of the log, and then became N log A X. Do you remember this law?
Yes, sir.
Good. So I'm saying that if this N, I'm taking it back to where it came from, it will just go and sit on top of the X again, isn't it?
Yes, sir.
Good. So the same thing is what we are doing here. I'm seeing 2 log 5. And I told you that I cannot apply the law of logs when there's a number at the back. So I have to find a way of removing this number from the back. And I told you that if I'm removing it, then it's going back to go and sit on top of the 5. That's where it came from. Festus, are you with me?
Yes, sir.
Good. So the 2 came on top of this and we had 5 squared and we had log 25. Do you understand that side too?
Yes, sir.
Good. So this 10 that I brought here, initially it was not there. If you look at the question, there's no 10 written anywhere. There's no 10 here, nothing, empty. But I'm telling you that in logs, anytime you don't see any number here, because in the laws that we have been writing, you have been seeing A throughout. So anytime there's no number there, the number which is supposed to be there is 10, but we don't normally bring it. So that was why I brought it here, to make it, because there's no number here, then it now becomes log 10, 25. Is it better now, Festus?
Yes, sir. Sir, it's clear now.
Very
Thank
good. So don't go off, stand there. Then I said that if I look at these 2, and I look at this log, there's no way I can combine them because these two doesn't have a log, but this one has a log. So the question is that, what can I do to these 2 so that I can use the law to combine them? And I'm saying that the trick which you are learning today is that if a number is standing alone like this, like 2 is the same as 2 multiplied by 1, because any number times 1, you get the same number. Festus, are you with me?
Yes, sir.
Very good. So then I remember that in logs, anytime you have the 2 numbers being the same, the base number and then the main number or the subject, the 2 of them are telling you that the answer for this law is 1. So question is, if 2 equals 2 times 1, what can I change this 1 to become? And that was where I said, the trick is that I'm seeing log 10 here. So can I change this one and make it log 10, 10? That is yes, because log 10, 10 will give me 1. So this log 10, 10 will now replace this one. Then I can write it as 2 log 10, 10. That is how come I brought this log 10, 10 here. Festus,
Sir,
are you okay now?
yes, sir. Sir, I'm okay now.
Very
Thank
good.
you.
Very good. I saw, yes, Joseph, I saw a hand coming up. I don't know whether it was, yes, Joseph.
Yes, sir.
Yeah, go ahead.
Okay, sir. Thank you very much, sir. Sir,
Yeah.
so the two minus log 25,
Mhm.
log 10, sorry, then 25. Let's say the question is like, in a way, 2 minus log 5, 25. It means, according to your...
No, take your time. I want them to understand the question
Okay,
you are asking.
yes.
So this is what Joseph is saying. Assuming it was 2 minus log 5, 25. Joseph, isn't it so?
Yes, sir. Yes, sir.
Good. So once it's like this, if I want to force and bring a log here, what do you think I'll write?
Uh, 2 log 5, then 5.
That's all. That's all, because the 5, 5 will take it to 1 and then come back to the 2. So before you write a log at the back of a number standing alone, check the log base you are dealing with. If it is 5, do it 5, 5. If it is 10, do it 10, 10. If it is 1,000, do it 1,000, 1,000. That's what we are learning today. That make sure you change it to the base of the one you are dealing with. So that was why here, when I saw that this is in base 10, I did it log 10, 10. So that 10, 10 will go to 1 if I want to come back to the 2, and then it will help me to be able to combine with the log I'm dealing with. So that's a good question, Joseph.
Yes, sir. So it means you just have to make sure whenever you deal with that log, the log that you want to insert, you have to get 1.
The base, exactly. You have to
Yes,
get 1.
1.
You have
Okay.
to get 1. So if it is 1,000, then you are going to do log 1,000, 1,000 to get your 1.
Yeah, yes, sir. All right, sir.
The numbers must be the same. Okay, Jonathan, I saw your hand up. Go ahead.
Yes, I wanted to just ask the question that Joseph asked concerning the 2 minus log 525. And
Yeah.
I wanted to say, what about when I do it, let's say the log 525 becomes 2. And then I just work directly with the 2 and 2.
So you mean like 2 minus
2 minus
log 5,
log 525.
5. Yes. Then you break this one to 5 squared, isn't it? And then you bring this to
Yes,
here.
sir.
Yeah, that can also work. That can also give you the results. But that's not the case we are having here. Okay.
Yes, sir.
The case here is simple, but this one is not simple because here is 10, here is 25. That is why we need to go through all we are going through currently. So that is also a good contribution. Now,
Yes, sir.
yes, so once we have it this way, then we remember again that before you can apply the laws, there should not be any number at the back of the log. There should not be any number. But look at this one. After writing this way, there's still a number at the back, which is not going to help us. So it means that this number, we have to send it to where it belongs. So it's coming on top of the 10. So this one will become log 10 squared minus log 10, 25. So we can go ahead and then expand this one. Log 10 squared is log 100. So we have log 10, 100 like this, minus log 10, 25. When you see it this way and there is no number at the back, it means that we can now apply the laws because all the back are clean now. No number here, no number here. So we can apply the law. Which law can we apply? The same base, log 10, log 10. The sign in between is minus, second law. So in applying second law, we write our solution as log. The same platform, 10, 100 will come on top, and then 25 will come below. Then we do the cancellation as usual. So 25 will cancel itself 1. 25 will go into 100, 4. Finally, we can say that our answer is log 4 in conclusion. So what I want to tell you today is that it is possible to add a real number to a log number if you know this trick. Anytime you have a number standing alone, you can add it to any log number you come across in this life. And that is the strategy we have used. So our final answer is log 4. Any other question before I move to one concerning this example? And I'm happy the way you are moving along with me. Your questions are showing that you are moving along with me well. So that is example 6 or exercise 6. Let's use the same strategy.
Hello, sir.
Yes, go ahead.
Yes, so in the chat, one of our colleagues had 2 log 2. And I suppose 2 log 2 is the same as 4. Is that it?
No, he is wrong. Actually, the
2
answer
log
we
2.
have, yes, the answer is wrong. The answer we have here is log 10, 4. You can't do anything about this. It's not 2 log 2. It's log 10, 4. Remember I told you that when there is no number here, it is base 10. It is base 10.
Okay. But sir, can't you convert 2 log 2 to the 4? 2 log 2.
Yes, so what I mean is that
Mm-hmm.
if you say 2 log 2, it means is
Okay,
this
okay.
4?
So I mean, okay, I understand. So you can't leave your answer
So
as 2 log 2.
if you say
Okay.
2 log 10 2, then I agree with you.
Okay.
If you say 2 log 10 2, so it's the way you are calling it. That is why I'm saying no, no, no. If you say 2 log 10 2, then I agree with you. Are you okay with that?
Yes, sir.
Right. So let's use the same strategy. Yes.
So with what Harry was saying, the 2 log 2.
Yes.
You initially said that if the log and then let's say the number are attached without any this in base, definitely it's in base 10.
Yes, but you see, our problem is that we started showing it here. Have you seen it? We have been showing it. So if you don't show it in your final answer, it's wrong. If we were not showing it, that's a different thing. But we were showing it throughout. Are you seeing it?
Yes, sir.
So finally, you have to come and show it. All right. So let's look at the next one, which is VII, half log 9 plus 1. Now I have taught you that it is possible to add a real number to a log number. That's what one of the things we are learning today. So let's work VII as our next question and see the results we get. So I want to write here. I need more space, so let me put it here. Our next question is we should solve half log 9 plus 1. So before we can apply the laws, we need to remove this half from the back and do something about this one. So let's do it one after the other. this half moves up here. So we have log 9 raised to the power half plus 1. 9 raised to the power half, if you remember the indices we did, 9 is the same as 3 squared. So if you have half at the top, it means you are multiplying the powers. So it becomes 3 raised to the power 2 times 1 over 2. If this and this cancel, you have 3 raised to the power 1. Any number raised to the power 1 is the same number. Okay. So this whole stuff here is going to be 3. So you have log 3 plus 1. How can we join these two numbers? We need to put them in the same log and base. Any log that is standing alone without any number at the base, it is base 10. So you put your base 10 there like this. You have log 10, 3. How can we make this one look like log 10? And you remember the law which says that if you have log AA, your answer is 1. Therefore, if we are working in log base 10, it means this one we can write it as log 10, 10, which will still give us the 1. So we replace it, and then it becomes log 10, 3 plus log 10, 10. So this has now become the first law. When you have the same platform, log 10, and then there's a plus sign in between them, you just multiply the numbers in front. So finally, our answer becomes log 10, 3 times 10. Then finally, we have log 10, 30 as the final answer. So this will be the final answer for question number 7, where we have half log 9 plus 1. And that sends us to question number 8, which looks a bit longer. So we are now here to tackle question number 8. Half log 25 minus 2 log 3 plus 2 log 6. Let's work it together and see the results we are likely to have. So I need to create some space here, and then we can work along. So those of you who are having a better understanding now, you can go ahead and solve it before we finish together. So you can check our answer with our final answer with the answer you have at your end. Let me write the question up here to get it more visible. So this is question number 8. Says we should solve half log 25 minus 2 log 3 plus 2 log 6. Half log 25 minus 2 log 3 plus 2 log 6. So let's proceed. This is the same as this half. We have to move it because per the law, there shouldn't be any number at the back of the log. This 2, we have to move it. Per the law, no number is supposed to be at the back. These 2 you are seeing, we have to move it. Again, per the law, no number is supposed to be at the back of the log. So let's proceed with that. We have, in rewriting, we have log 25, where the half will come and sit on top here like this, minus the 2 is also moving to sit on top of 3, so minus log 3 raised to the power 2 plus this 2 is also going to sit on top of the 6. Have log 6 to the power 2. Now log 25 to the power half is the same as square root of 25. So you have 5 minus log 3 squared is 9 plus log 6 squared is 36. So we have logs without numbers at the back, giving us an indication that we can now apply the laws. Now, when it's minus, it means we are applying second law. When it is plus, it means we are applying first law, meaning we are applying both first law and second law here. And let's do so. So for the second law, we have log 5 divided by 9. And then first law says that multiply. So by 36. And then we do our cancellation. 9 will cancel itself 1. 9 will go into 36, 4. We can finally say that our answer is log 5 times 4 is 20 divided by 1, which is the same as log 20. And this becomes our final answer. Any question about this? That is our final answer, log 20. We have combined 3 laws. The first law was the third law. We used the third law to bring the half to the 25. We used the second law to combine the minus, and then we use the first law to combine the plus. Yes, Joseph.
Yes, sir. Please, sir, can you go over and start from the second step, log 5 minus log 9 plus log 36? Thank you.
So log 5 minus 9 is second law, so 5 will be up, 9 will be down. Plus means that the number should multiply at the top. That is why we multiply the 36. Is it clear?
Yes, sir. Very well, sir.
So always remember that if it is plus, the number will be on top. If it is minus, the number will be below. So that is how we had, yes, that arrangement.
All right. Thank you, sir.
Okay. Any other question on this?
Sir.
Yes, Harrison.
Yes. So, sir, can you kindly evaluate the half? You said that we had 5, right?
Okay. I want to know why we had a 5.
No, I know. Yes, I know how we had the 5, but evaluate it, like explain further. You just mentioned that square root of 5, 25 to the power half is the square root of 5. So let's show it by showing working, like show it working.
Okay, so yeah. All right, I get you. So 25 to the power half in indices means we should break 5 down to the smallest number, and 25 is the same as 5 squared. So when we get it 5 squared, and then we have half like this, then you remember the third law of indices. The third law of indices, we said when you have AM, all close, and then there's another power N at the back. The law said that we should multiply the powers. So we ended up having A to the power M times N. And if you
Sir, please, your line is breaking. I can't hear you.
Direct, you can call him privately because I can't hear anything.
Hello, sir.
Okay, so the network was a challenge. All right, so can you hear me now?
Yes, sir, we can hear you.
Who even asked the question? Was it Joseph? Are you okay now?
I'm okay.
It was Harrison.
Harrison. Oh, sorry, Harrison. Okay, Harrison,
Yes,
it
I'm
was
okay.
right.
Yes, perfectly so. Thank you,
Very,
sir.
very good, very good, very good.
Yeah,
So
you're a good mathematician. You're a good mathematician.
thank you. Let's continue. So we are now at the ninth one, Ix, log 9 over log 3. Log 9 over log 3. So let's see how we can simplify this one to your amazement. And we'll follow just some few steps. And for this one, we can break this 9 down to 3 squared. So log 9 divided by log 3. All we do is that we can see that this 9, we can break it to 3. So it's the same as log 3 squared divided by log 3. And we said when logs meet like this, we don't entertain powers. So we use the third law to send this power to the back of the log. So this will become 2 log 3 divided by log 3. Once we have a common term, we can cancel. This log 3 will cancel this log 3. And then finally, the answer becomes 2. So that is an easy step for us. 2 3 squared divided by log 3. We send the 2 to the back of the log. And then you can have same log 3, which will cancel out, and then you'll be left with the 2. So that is the answer for IX.
Okay, sir.
Yes.
Is there another way you can use to solve this one using where you would, I mean, one of the logs, the laws of logs, where
yes,
you,
there are other ways, and that is a good question.
Yes, that is what I wanted to know.
Yes, there's other ways. So this one, if I want to use the other way, what I'll do is that I'll change this sign I'm seeing here to division. But that's going to take a long process if I change them into division. So if you also want to use log 10, you can put the 10 there. But because the laws are log AX minus log AY equals log AX over Y. This X over Y is different from log 9 over log 3. So it becomes difficult if you want to use this way. So the only way to use is what I said. You introduce 10 to all of them like this, 10, 10. And once you introduce the 10, you rewrite them as log 10, 9 divided by log 10, 3. And then you pick this one separately. So you have log 10, 3 raised to the power 2 divided by log 10, 3. Then finally, this will come here. So you have 2 log 10, 3 divided by log 10, 3. So log 10, 3 will cancel log 10, 3, and then you still come back to the 2. And that is the only way you can work it, apart from the way we work it, the first one. Yes, I saw a hand up. Yes, Jonathan.
Yes, sir. It seems that with this one, certain of the laws of indices do not apply, because look at this one with the exponent and then the 3, even let's say the log 3 squared over the log 3, where in the with the laws of indices you can deduct 1 from the exponent of the 3
Yes,
3 squared.
yes, exactly. That's what I'm saying. That because of the way the law is, you cannot do it like the indices. That was what I was saying. That because of how it is, you can only concentrate on 3 squared and 3 because there's a log. So if you do that, you make a mistake. Now this is the difference. If you see log 3 squared divided by log 3, it is not the same as log 3 squared divided by 3. They are two different things. If it's log 3 squared divided by 3, then I can cancel this and this. But once there's a log here, you cannot cancel this and this. It will not work. You have to rather move this one so this and this becomes the same before you can cancel. So that is the difference between the two. All right. So let's move on to our next question. So we have how many more to go? 1, 2, 3. Okay, we'll finish very soon. Let's look at the next one, log x plus 1 minus log x squared minus 1. So this is also an interesting question which demands a lot of algebraic manipulations. Let's see how we can simplify it to the barest minimum supposedly. So let me write the question here and then we can do it together. So I write the question. Log x plus 1 minus log x squared minus 1. So there's a mathematical trick that we need to know. If we don't do it, it will worry us. Now, I hope you know that x squared minus 1 is the same as x squared minus 1 squared. X squared minus 1 is the same as x squared minus 1 squared, because 1 squared will give you what? 1. Okay, right. And then I'm sure those of you who remember at the lower levels, you were taught something about difference of two squares. Difference of two squares. We want to apply difference of two squares to break down this expression. So in difference of two squares, they said if you have something like a squared minus b squared, you were taught that open two brackets, first bracket, second bracket. Two squares, a squared means write a 2 times. So you write a here, you write a here. B squared means write b 2 times. You write b here, you write b here. Okay. Now when b is crossing the equal sign, it is minus. When it crosses the equal sign, it will become plus. You put the plus here. When b is coming back, it will still come with a minus. You put the minus here. And so this becomes the results, that anytime you expand a plus b, a minus b, your final answer will be a squared minus b squared. If I use this one to what I've written here, x squared minus 1 squared, and I put it this way, x squared minus 1 squared, it qualifies under difference of two squares. It means I should open two brackets. The first number, x squared, I should write it 2 times. So x here, x here. The second number, 1, I should write it 2 times. 1 here, 1 here. When minus 1 is crossing the equal sign, it will become plus. When plus 1 is crossing the equal sign, to become minus 1. So this will be the answer, meaning that this x squared minus 1 you are seeing here, we can rewrite it as x plus 1, x minus 1. And let's see how it can help us solve this question. So in rewriting this question, I have log x plus 1 minus log. Instead of x squared minus 1, I'll rather use the simplified one, which is x plus 1, x minus 1. And then I'll remember the second law. of logs. The second law says that when you have a minus sign, it means that this first one will be on top, the second one will be below. So we'll have this as log x plus 1. Because of the minus, it becomes all divided by x plus 1 x minus 1. Let's see whether there's a cancellation we can do. I see x plus 1 here, so this x plus 1 will cancel this x plus 1. And so finally, I'll be left with log 1 divided by x minus 1 as my final answer. So this will be the final answer for question number 8. Any question about this long solution before I go to the next question? This is how you can solve it. You can only use difference of two squares to break them down so that some things can be able to cancel out. And then this long expression has been reduced to this short expression as log 1 over x minus 1. Any question? Okay, so I presume you are okay with that solution. Let's look at the final two. Let's look at the final two. The final two we have here is xi and xii. Let's solve it together. Now we are seeing alphanumeric. We are seeing alphabets together with numbers. Let's see how we can put them together in order. So let's start. Now, this 2 here, we need to move it, else we cannot use the law. This 2 also here, we need to move it, else we cannot use the law. So it means that in moving it, we can rewrite this one as log A, and then we have 5. The 2 is coming, so it becomes 5 raised to the power 2 plus this one will still maintain its log A 4 minus this 2 is going on top of the 10, so it becomes log A 10 raised to the power 2. Okay. Now let's simplify it. So this will give us log A 5 squared will give us 25 minus the second term, will still maintain it. No work to be done on it. Log A4 minus the last term, we have log A 10 squared is 100. So we are back to business now. There is no number at the back of all the logs. Here is empty. There is empty.
Is it log 25?
Sir, please.
Is it okay?
It's
Plus.
25 plus log 4.
All right, thank you. So 25 plus 4. Right, thank you for correcting the typo. So we then use the laws. Now that we have no numbers at the back, we can then use the law to put them together. So the same platform, log A, log A, log A. So we are working on the same platform, log A. Then plus means multiply the numbers in front of the log. So we have 25 times 4 divided by, minus means divide. So we have 100. Then let's do some cancellation. So we say 4 comes here 1, 4 goes into 100, 25. 25 will cancel itself 1. It will cancel this 25, 1. So finally, this is the interesting dynamics we have. We have log A, 1 divided by 1, which will finally give us log A, 1. If you remember the laws I gave you, I told you that the log of 1 is always 0, irrespective of the base. Once you get log 1, it means that the answer is 0. So our final answer is 0 because we are having log 1. You can press it on your calculator. Just press log 1 on your calculator. It will give you automatic 0. Log 1 is always 0. Somebody may ask, why is log 1 always 0? This is the reason. If I have log A, 1 is equal to 0. Anytime I make attempt to send this A to the side, when I'm sending this A to the side, this log will also move away. Okay. Anytime you try sending this base to the side, this log will also move away. So when this log moves away, you'll be left with only the 1 standing here like this. Okay. And then this A that is moving to the side is going to carry the 0. It's going to meet like this. And you know that any number raised to a power 0, the answer is 1. That is why log A1 will always give you 0. So that is the solution for 9. 2 log A5 plus log A4 minus 2 log A10. The answer is 0. Then let's finally end with XIII, log 125 divided by log 5. Log 125 divided by 5. So the first thing we do is that, can we write 125 in terms of 5? You could use your calculator to do that. 5 multiplied by 5 will give you 25. When you multiply 25 by 5, that is going to give you 125. Okay. So it means that 125 is the same as 5 times 5 times 5, which is the same as 5 raised to the power 3. Writing 5 3 times. So that's the breakdown we are going to have here. We have log 125 is the same as 5 raised to the power 3 divided by log 5. We don't entertain powers in log, so we send this one to the back of the log, and we can rewrite it as 3 log 5 divided by log 5. Then we can do some cancellation. Log 5 will cancel log 5. And then our final answer will be 3. And that is the last question we have solved on the logarithms. Any question about this before I proceed to the next thing I want to do? Any question about? Yes, Joseph.
Yes, sir. Thank you, sir. So, my question is the log 125 over log 5. It means
Yes.
whenever you have a question like this, you have to make the base the same. I don't know
In
what.
fact, no, when you have a question like this,
Okay.
there's no base. You have the subject numbers.
The subject, yeah, sorry. The subject.
Yes, you have
Platform.
to. Yes, you have to try. You have to try and make them the same. If you are not able to make them the same, then there's nothing you can do.
Oh, okay.
Yes.
All right, sir.
If
Thank
they are
you.
not the same, there's nothing you can do about it.
Thank you, sir.
Okay. Any
Yes.
other?
Can
Yes.
we solve one more on maybe different question on that?
Don't worry, we'll come back to log. I want to do another thing.
All right, sir.
So there are
Okay.
more log questions we can work later. All right, so let's move to our next topic for today. I don't know whether we did it. Did we do laws of indices the other time? Anybody can respond.
Yes.
Yes, sir.
Yes,
Yes, sir.
sir.
We did it.
Very good. Then
Yes,
let's
sir.
go. Okay, so let's go solve.
Um,
Did we solve a question here?
No, sir.
Good. So we are going to solve here. Then I think I did this with another class. So let me clean this and then let's come and solve a couple of questions here. And then we'll be done with this topic. Okay, so everybody must mute. Please, if you are live, just mute yourself. Okay. So we want to do sets. Sets are irrational numbers. Numbers that do not make a lot of sense on the face value, but they are very needful in some computations or calculation in our business world. So we want to know how we can calculate such things. We'll take our time and walk through very interesting expressions. And I'm sure at the end of the day, you can master the small tricks that are needed in some of these computations. So let's pick a lot of questions, and thankfully there are answers. Look at the answers. All the answers are here. So when we work, we check with the answer to be sure that we are correct. So the questions runs from A up to R. Let's do as many as possible before our time is up. We have about 40 minutes, and I know the 40 minutes we can use to work a lot. So let's start with the first one. We are working the sets. It says simplify the following: square root of 175 minus square root of 252. Let me write it here. Let me first of all get a lot of space and then we can proceed. So let's write the question and then proceed. So we are supposed to solve A, question number A. We are supposed to solve square root of 175.
Yes, sir. Hello, sir.
Yes, go ahead.
Yeah, so please, these questions and answers, can you kindly forward it to the class rep for our platform for us so that in our close sets we can try and answer them?
I think it is in the group.
It's in the group. This is there.
Oh, okay.
Yes,
Okay.
it's there.
Thank you.
Maybe the Easter has made you not read the notes, so you don't know.
The light off, the doomsday is worrying us here.
Don't worry, it will be well. Don't worry, small. Don't worry, we'll all pass through. Don't worry. Okay, so thank you for responding that it's in the group. We are doing 175, square root of 175 minus square root of 252, and the answer should be -7 at the end of the day. So let's work it out. Now, what is the strategy? What is the first thing to even think about in tackling this problem? The first question you ask yourself is that, what are you thinking about? Now, this is the strategy. the strategy is that ask yourself that what can you do to this 175 so that one number will come outside the root sign and the other will stay. In other words, if I give you an example like this, square root of 50. I want to give you an example. Square root of 50. The question is, what is making the 50? I know 50 is the same as 5 times 10. 50 is the same as 25 multiplied by 2. So the question is, if I put these two under the square root sign, which one will reduce the 50 for me? In other words, if I write square root of 5 times 10, and I write square root of 25 times 2, which one will be simple? Now, when you take this one, square root of 25 will give you 5. So the 5 will come out. And then the only thing to be left inside the square root will be 2. But the 25 has gone out because you've been able to find the square root. So it has reduced nicely. The square root of 50 has reduced nicely to 5 outside and 2 inside. But when we take 5 and 10, I can't find the square root of 5. I can't find the square root of 10. So in that case, no number can come out. I'll still be at square root of 50. But the question is also saying that simplify. Look at the word. Simplify. Make it simple. So if I'm not able to get some numbers out of the square root sign, then it means that I'm not making things simple. If I compare these two examples, I have made things simple here, that square root of 50 can be written as 5 root 2. Why? Because the 25 can come out of the square root sign. And that's exactly the same thing we want to do here. Yes, Jonathan?
Then can you say that to be able to find the let's say the values after the simplification of the numbers in the root, you have to now divide the number in the root by a perfect square, and then if you are able to find that perfect square which divides it without a remainder, then you are going to use that one.
Yes, you can. You can, but sometimes there are simpler inspections you can do. There are simpler inspections you can do. So sometimes you go by the inspection and then you go along with it. So like you were saying, I know that any number that's ending with 5, it means you can try and divide it by 5 and see. So take your calculator, do 175 divided by 5. What are you going to get? You see that when you do 175 divided by 5, you will be getting 35, isn't it?
Yes,
Hello,
sir.
sir.
Very good. So,
Hello, sir.
yes.
I was saying that the division of it, no, you should find one perfect square. Like let's say the 25, the 100, the like 4. You see the numbers which are perfect squares to whose square roots can be found with ease, and then you divide by those numbers in the square root, so that it makes more easier than dividing by like gradually by the 5 5s.
Okay, repeat what you said, Joseph. The network was breaking.
Yes, sir. So I was saying that the division, yes, dividing, finding the two values which would be used in place of the numbers in the original, let's say the original question. So let's say if we take like the 175, Then we divide by a perfect square. Like perfect squares like the 4, 8, 25, 100, and then like 49. So we divide those by the number in the root, so that now you find any, if any of them divides with without any remainder, then we could use those ones for
So that was where
this in
that was where I was coming to. That was where I was coming to.
Yes, sir.
Do you understand it?
Yes, sir.
Not everybody understands the perfect square. That is why I'm breaking it down for you. That you be like a layman, you don't know what you're about. You just want two numbers to be multiplied so that you get 175. And then I'm saying that once you see 5 here, then you try 175 divided by 5. What will it give you? Your calculator will say 35. So it means that 175 is the same as 5 times 35. Like the previous example I gave, if you find the square root of this one, no number can come out. You can't find the square root of 5 directly. You can't find the square root of 35 directly. So it means that even though 175 divided by 5 is giving you 35, this is not going to help us. So what can you do? Can you still break this 35 down? You see that this 35 too, when you try breaking it down, you come and get 5 multiplied by 7. So in that case, the 175 has become the perfect square you are seeing. It becomes 5 multiplied by 5 multiplied by 7. And you know that 5 multiplied by 5 will give you 25. And so if they are under the square root sign, 25 can come out. Square root of 25 will give you the 5. The 7 cannot come, so the 7 will remain inside. And then the thing becomes simple like this. So the perfect square Joseph is trying to let you people know was the last thing I wanted to add. That he's saying that when you have a number and you want to get two numbers in which when you multiply, you get the number under the square root sign, just divide the number by the perfect square. Now, what is a perfect square? A perfect square is like you have a square in which the length and the breadth are the same. Like you know, a square, the length and the width are the same. That's the perfect square he's talking about. So if you are picking out the perfect squares, it means you can have 2, because 1 times 1 will give you 1, and then the next is 2. So 2 times 2, then you go to 4. So then if you write out the perfect squares, you go 4 times 4 will give you 16. 2 times 2 will give you 4. So you keep on going, and then 6 times 6 will give you 36. 7 times 7 will give you 49. You keep on going. Now, when it comes to this number, you ask yourself, okay, 5. I was thinking of 5. What is the perfect square using 5? That's 25. So when I divide this one by 25, what at all am I going to get? So like he was saying, if you divide this by a perfect square, 25, the answer will give you 7. In other words, 175 is the same as 25 multiplied by 7. And once we know we can find the square root of 25, it means this can be replaced here. Again, with the explanation he was giving. if you are using 2 as a perfect square, 2 times 2 is 4. When you divide this 1 by 4, will you get a number without a remainder? No. So it wouldn't work. When you use 8, will it work? No. When you use 10, will it work? No. So once we have the 5 here, like I was going gradually, 175 divided by 5, you get 35. So you ask yourself, can we break down the 35 to? Yes, we have 5 and 7. So this one will become 5 times 5 times 7. This way. Now, what is 5 times 5? 5 times 5 is 25. So you have 25 times 7. So the first one, you've been able to break it down to 25 multiplied by 7. Now, all the work has been done here. Once you get this one correct, the second one becomes easier. So the second one too, what is going to happen is that make sure the number here, which is not a perfect square, the 7, you are going to divide this number by this on your calculator, and then you put the result here. Now, 252 divided by 7 on your calculator, what are you going to get?
36.
36, very good. So it gives you a perfect square, 36 multiplied by 7. And so once you have them this way, look at what I did here. When we struggle to do this one, the number in which you cannot find the square root of, that is what you repeat here by dividing it by the number here to get the breakdown. So in the final analysis, square root of 25, 5 will come out. Square root of 7 cannot be done. So it remains in the square root sign minus square root of 36 is 6. 7 cannot come out. It will stay there. So once you have the same numbers under the square root sign, then we apply the second law of Z, which says that if you have A root M minus B root M, your final answer is A minus B root M. And that's what we are doing. So here, 5 root 7 minus 6 root 7 will give us 5 minus 6 root 7. 5 minus 6 root 7. Now the question is, what is 5 minus 6? 5 minus 6 is negative 1. Let me create a space here. 5 minus 6 is negative 1. So we have negative 1 root 7. But in mathematics, when you have root sign, we don't write the 1. Okay? So finally, we have negative root 7. And that is the answer we have here. Negative root 7 as A. Any question about this before I go to the next one? Okay, so we are using the same strategy. Yes, Joseph.
Yes, sir. So finding the perfect square, after finding the perfect square, and then let's say the 25 times 7. When you're done with the first, let's say finding the first one, it means the second, the 7. When you are going to find the next, that's the square root of 252. You just have to find the number that you can multiply and then get the with 7 and then get the
That's all. That's all. What you even do is that just type on your calculator 252 divided by 7. 36 will come. Then put the
All right.
36.
All right, sir. Thank you very much.
That is why I said all the work is done with the first one.
Okay,
Once
sir.
you finish with the first one, the second one becomes easier.
Okay, sir. Yes,
Good.
sir.
So we use the same strategy for B. Square root of 44 plus square root of 99. So again, we come back to the perfect square thing, which I know it will take some time for some of you to understand. But the question is that 4 is the same as 2 times 2. So that is perfect. 4 is the same as 2 times 2. That's perfect. So can we divide this by 4? Yes. Let's divide this by 4. When we divide this by 4, we are going to have 11. So it means that by implication, 44 is the same as 4 multiplied by 11. So the question is, can we find the square root of 4? Yes. Once we can find the square root of it, then it's a perfect square. So we'll leave this one like that. What about the second one, 99? I said that one we don't struggle. The one that is not a perfect square, you are just going to divide it by the 99 and something will happen. So if you take the 99 and then we write this 44 as 4 times 11 plus, then the 99, we just do 99 divided by 11. What will you get? It will give you 9 times 11. Meaning that 99 is the same as 9 multiplied by 11. Can we find the square root of 9? Yes. So it means that that's a perfect square number. So square root of 4, 2 will come out. So we have 2 root 11 plus square root of 9 is also 3. So we have 3 root 11. At this point, the numbers in the root signs are the same. So we can use the first law. The first law says that if the numbers that are under the square root sign are the same, just add the numbers in front, which is 2 and 3. So finally, we have 2 plus 3 root 11. 2 plus 3 is 5. So it means that finally our answer is 5 root 11. Let's check the second answer. That's what we have. 5 root 11. So the second one is also done. Any question again before I move to the third one? Because I want you to get it before we close. Okay, let's move to the third one. So the third one, we have a lot of thinking to do. Square root of 468 minus 208. So what is the thinking to do? How do we break this one down? Any suggestion before I say what I want to say? How do we break 468 down? Who has an idea?
Please, question again.
Yes, I'm asking that. How do we break 468 down into two numbers where we can find the square root of 1 to come out?
Okay, nice. Okay, so okay.
Yes, sir.
Yeah, I'm listening.
Okay, sir.
I'm listening.
You divide by 13.
So how did you get it? That's
I will divide.
what the class wants to know. I want to say something. So how did you get
Okay,
it?
so I divided by the perfect square 36.
No problem. Why did you divide by perfect
468.
square? No, why did you divide by perfect square 36? I want to throw some understanding. That
Okay.
is why I'm quizzing your mind.
Yes, sir.
Why did you decide?
Yes, I started with the, let's say, okay, I started with 25 and then I went to,
Why did you
I just,
start with 25?
yeah, because I know that the lower ones would not actually match the 208 when you even find the absolute, the division for the 468 by the number. It
So
means
that
that
is
we
the
are,
understanding. No, that is the understanding I want to give the class. That there's a strategy. If you get the strategy, you will not think too much about what to do. Now, normally, what is done is you are breaking this number into two numbers in which you can find the square root of one of them. This number seems so big. So if you say you are dividing this number by 2, by 4, by 5, by 6, by 7, by 8, by 9, by 10, you will see that you will not be successful because these numbers are very big. 4, 6, 8. They are very big. So what you do, like he started from 25. Don't start from 25. What you do is 468. If you divide by 10, for instance, you have 46.8, which will not help you. Then you move on. Then you divide it by 11. I just want to shorten the movement for you when the number is big. If you use 5, you'll be far away.
So you can
If you
divide
use,
by 2.
pardon me?
So you can divide by 2.
Yes, so I'm not saying you can't divide by 2. I'm just shortening it for you. Okay, fine. So when you divide this one by 2, what will you get?
So you get 2, 3, 4.
Very good. And then what will you do again?
And then you would also divide by another 2.
Aha. So if you divide by another 2, what will you get?
117.
And then what do you do again? And then you get stuck, isn't it?
Yes, sir.
Very good. That is why I didn't want you to start from the 2.
Okay.
When the digits are in 3, when the digits are 3, you don't start from 2, you struggle. So that is why I'm showing you that let's go beyond the 10 when you have digits that are more than 2, for instance, like this 468. So when you divide this one by 10, I'm saying you get 46.8, which is not going to work out for us. So that is off. Now, then we are moving forward. So divide it by 11. And let's see what you get. Before we come to the 13 Joseph is talking about, I want you to show you where we will get to at the end of the day. When you divide 468 by 11, what would you get? You'll get a funny number.
Yes.
42.5454.
42.545.
So the moment you see something like that, it means it's not going to work.
Yes.
And then you keep going. Then you divide it by 12.
12 is 39.
Good. So 12 is 39. Then you ask yourself, can you find square root of 39? No.
No.
Good. Then you move to 13. So move to 13. What will you get?
36.
Very good. So it means that once you get a number in which you can find the square root of 1, you have the answer. So this is what Joseph is saying. I was asking him a question because he wasn't able to respond. That is why I stopped him. I asked Joseph that, how did you get a 13? He said,
Sorry, sir. Sir, it was Hassan, not Joseph.
Oh, okay. Thank you. And then he said that he started from 25. And I was asking him, why did he start from 25? But he couldn't tell me anything. I was expecting him that he would say that, okay, when I divide this one by 25, I don't get a number in which I can find the square root. Because he was doing the right thing. He knew that these small numbers will not work. So he was taking their perfect squares. He knows that the perfect square of 2 is 4. Perfect square of 4 is 16. So this is what he was doing. Instead of him dividing by the lower numbers, he was using the higher numbers, which is quicker. So I was expecting him to tell me that I started from the lowest perfect square. So I started from 4. I divided by 4. I didn't get any reasonable number. I went to 16. I didn't get any reasonable number. I went to 25. I didn't get any reasonable number. But when I went to 36, I had a reasonable number. So this is where he had his answer from. When he divided 468 by 36, he had 13. Okay, he had 13. That means that there was no remainder. 36 times 13 will give you 468, in which you can find the root of 36. So once he had this one, then life becomes easier now. 468 becomes root of 36 times 13 minus, then here you don't have plenty thinking to do. All you do is that you divide this one by the one you can't find the square root, which is what? 13. 208 divided by 13. What are you getting?
16.
16.
Very good. So you have 16 times 13. Then you are ready to work now because some of the numbers you can find their square root now. Square root of 36, you have 6 root 13 minus square root of 16 is 4. So you have 4 root 13. And so you have root 13, you combine the numbers in front. So you have 6 minus 4 root 13. And then finally, you have 2 root 13 as your answer for C. So let's check C. So that is the answer, 2 root 13. Okay. So now the strategy now we want to learn is that when you are dividing the lower numbers and it's not working, then you work with the perfect squares to see whether you can get your answer faster. When you are working with the lower numbers and it's not working, you start working with the perfect squares. And the lower number you can work with, first of all, is 4, because 4 is a lower number. At the same time, it's a perfect square. Okay. then you can continue 16, 25, 36, and so on and so forth. So let's go to D and see the strategy here. How we can now use the perfect squares to work. So the perfect squares, we have 4, we have 9, we have 16, and I know you know all of them. This is 2 squared. This is 3 squared. This is 4 squared. We have 25. This is 5 squared. And then we have 36. This is 6 squared. So we use it to root 45 plus root 80 minus 3 root 20. So you ask yourself, which perfect square can we divide by 45 and get two numbers in which the perfect square will come out? So we start with 4. The first perfect square, 4. Now, can we divide 45 by 4 and there will be no remainder? No, it will not work. When you divide 45 by 4, there will be a remainder. So it will not work. Then we move to the next perfect square, 9. Can we divide 45 by 9 and there will be no remainder? Yes. 45 divided by 9 is 5. So it means that 45 is the same as 9 times 5. So once we have this one, then the rest should be easier for us. So this is how the rest is going to be. 45 will become square root of 9 times 5 plus the 80. We don't have any thinking to do. The 80 means we should just divide 80 by the 5, which is not a perfect square. When you divide 80 by 5, what will you get?
16.
So we have 16 multiplied by 5 minus, then we have 3 square roots like this, 20. When we divide 20 by 5, what will you get?
4.
Oh,
So this is 4 by 5. So things are becoming clearer now. Then we simplify the square root of 9, the perfect square, is 3. So you have 3 root 5 plus square root of 16 is 4. 4 root 5 minus square root of 4, but there's 3 here already. So the 2 will come and multiply the 3, and then you have 6. You have 6 root 5.
5.
So you see that after bringing all the perfect squares out, now we have 5, 5, 5. So we can combine the outside and then have the final answer. So we have 3 plus 4, which is 7. 7 minus 6, which is 1. So our answer will be 1
root
5.
5.
But I told you that in sets, when it is 1, we don't write the 1.
So root 5.
Answer will be square root.
Yes. 5.
And that is D. Let's check our answer for D. So that is what we have here. Square root of 5. So it means that the strategy has worked for the 4 we have done. Unfortunately, our time is up. So what I expect is that please go on this page with your friend or you alone and try and work out this stuff. Once the answers are here, just be cross-checking with the answers. The ones that becomes too difficult, if we meet again in class, God willing, next week, we can look at them and then solve them appropriately. Any question before I close the class today? Any question on what we have done? All right, so on that note, we want to close the class for today, and we adjourn it to next week, God willing. I wish you a good day and a good weekend. The meeting is ended.
So I'm hearing that the woman saying was big, and I just have.
Joseph.
I feel a grapevine that
Joseph.
I hear from latest that he's negotiating for hosting the
Joseph.
next. I know you're probably thinking of something crazy. Yeah.
Hello, Joseph.
Yeah, Hassan, please DM me, okay?
Because the icons are here. Someone came on board this year. We launched this event a little bit a week ago. High expectations
Hassan,
for the
sorry, Harrison.
Yes.
Please DM me.
DM our response.
You're expecting that below for great tournament. I'm happy to be part of this event. My expectation was high, and this is beyond my expectations. So everything went. Without saying everything went well. The kids also played their hearts out. Everything I just essentially no violence, no injuries. Everything ended well. So. And I can't wait for next year. So you saw the goal in the final. The chip, they won the cup. And this is the goal. A young boy at that age scoring that goal means that they have a bright future. So we have to just support them and then keep praying for them. So the near future we might have there are some agents and the appears and everybody who have been a middle in this kind of tournament. And so kudos to them and I wish them well. Kudos for you to be one you came to show them the skills and then you came to encourage them today. And you saw the top scorer. I'm sure we are going to have a new Asamoah man of this thing. Not everybody will get to that level. So we pray you can see a lot of this boys achieving their dreams in the next step matters. That's the next step. The next step, everything will depend on them. They have the exposure and everything, and the rest is on them. How they get themselves and then stay humble and then play as a team, and then we see what happens in the future. Thank you very much. Asamoah, let me just say, Sam is also here. He was in the EXCO of the Ghana Football Association. You've been involved in coaching football and all of that. Now that we are done, from a football perspective, football administration perspective, what should happen there? Should take this case, the should make sure that they will go to the top because the quality we saw with the boys, then we guide them and we give them the right support. We are going to get the next thing, not the same as well, at least some talent who comes up the Asamoah and the Napias and all the legends we have in this country. This is point. And I want to thank Widow for doing this, and I want to people that post with this and do more of it. God bless you. Because we know what you've done for the years. I remember those days when we were all people post. And I love Samir, thank you very much. And that is how we draw curtains live on TV3 as far as this event is concerned. The 2026 edition of the Milo Champions League has come to an end here at the Essuman Sports Stadium in Second D. The winners, the new winners from the Eastern region of Ghana, Salvation Army Primary School from Nkoko in the Eastern region. The Greater Accra School, Pavenia Atomic LA Primary School coming second, and Chemuesie and Rumakabe Primary School coming third. But we know all the 16 teams from all the 16 regions that participated in this competition are winners, and now we have to nurture these players. We are building champions, but these boys need to go through the processes of becoming champions and becoming talent number 7 on international tournaments. So from the Essuman Stadium, Right here in Second. Thank you very much for joining TV3.